fractions. 4x minus 2 equals 3. What is the value of 2/5 x minus 1/4? And so you would just solve for x and then plug that whatever value you got for x in right here. Do the multiplication by 2/5, subtract 1/4, and then see what you came up with. Apparently, you would come up with 1/4. Okay, so that's what this two-step problems is about. It's just they're asking you to solve one problem and then use the answer to that problem to solve another one. Okay. Now then, we've got adjacent angles, complementary and supplementary angles, and measuring angles. Measuring angles involves using a protractor. If you have not used a protractor, it's fairly simple. You almost need to have one to kind of practice with it, but it's a transparent plastic apparatus that has all these angular markings, and it has a hole here, usually a hole or maybe a crosshair. Crosshair like something like this, or it might have some fancy crosshair, whatever. And so what you do is you center. If you've got an angle, you try to center the vertex of your angle. If you're measuring this angle here, we'll call it theta. You center the vertex of your angle right there in the middle of the hole or the crosshairs of your protractor, and then you read the measure of that angle over here, and you'll notice that it's got some numbers on the inside and some numbers on the outside. Well, we obviously know that this angle is less than 90, and so we're not going to take the large angle on the outside of the scale. We're going to take the smaller angle on the inside, which looks like it's 45 degrees. The larger angle is if you've got an angle that is was that an oblique angle? It's larger than 90 degrees. And so you see if this angle, instead of being this angle like this, it were an angle like that, then you would take the larger number, and it would be 135. Okay, so that's how you use a protractor, and they're going to talk to you about that. But the other things that they talk about in there, they're talking about complementary and supplementary angles, and adjacent angles. So, and they also talk about how you name angles, and so that stuff's fairly self-explanatory. I'm gonna let you read that, because you should always read your section, because there's good stuff there, and they don't generally take a whole lot of time to say it. But basically, it's if you've got an angle and you've got any kind of points along there, you can name your angle by any of the combination of the points. Like let's say this is A, B, C, D, E. So you can name this, and so the vertex, it basically would be the combination of a point on one of the rays, a point on the other ray, and then the vertex. So this angle could be properly named ACD or ACE or BCD or BCE or ECB or DCA. I mean, you can do it any direction. As a matter of fact, right here, they do just that. They show you that this angle right here, this angle has 8 names, and so they go through all that. Now then, so a complementary angle is you talk about an angle being complementary to another angle. Okay. Well, first of all, let's talk about adjacent angles. So if you have two angles that have the same vertex, okay. So here's the vertex. Okay, we've got these two angles, theta, and we'll call this one phi. Okay, Greek letters, don't know why. So these two angles are said to be adjacent to one another because they have the same vertex and they share a common side. Okay, so these two angles, theta and phi, are adjacent to one another. These two angles are not adjacent to one another. Okay, let's just add to our picture. Make it straight. And let's say this is rho. I think that's rho. Yeah. Anyway, so this angle right here is not adjacent to either one of these angles. It's not adjacent to phi or to theta because it does not share a vertex with either one of those angles. So this is not an adjacent angle to either one of these. Now then, so now that we've talked about adjacent angles, if you have two adjacent angles that add up to 90 degrees, so let's say this is phi and this is theta, then theta is said to be complementary to phi, or they are said to be complementary angles, or phi is said to be complementary to theta. If this is, if this is a right angle, if let's say that this is point A and this is point B and this is point C, if you're told that point ABC is a right angle, then theta and phi are complementary. Not complementary like they tell each other, you look lovely today. No, you look lovely. No, you look more lovely. Complementary with an E instead of an I. Okay? And that means that they add to 90 degrees. Okay? Now then, if you have two angles that add to 180 degrees, I'm going to erase this. If you have two angles that add to 180 degrees, so here's this line is 180 degrees, and here's our vertex. Whoop. Okay, so let's say this angle is our theta, and this angle is our phi. Then theta and phi are said to be supplementary angles, or theta is supplementary to phi, or phi is supplementary to theta. These are supplementary angles. Okay? Supplementary. Okay? They add up to 180 degrees. That's supplementary. Okay? So, and these are adjacent angles because they share a vertex and they share and they share a side, right? And they share a ray right here and the vertex. All right? So complementary angles, supplementary angles, and adjacent angles. Now, two angles don't have to be adjacent to be complementary or supplementary. That's just an easy way of illustrating it. You can have an angle over here that is, let's say this angle is theta, and you can have this angle over here completely disjoint and disconnected, and we're going to call this angle phi, and these two angles might actually be complementary, meaning they might actually add to 90. If for example, if theta equals 30 degrees and phi equals 60 degrees, well, these are complementary angles. They add to 90 degrees. They don't have to be adjacent to be complementary, and in the same way, they could add to 180 degrees and be supplementary without being adjacent, okay? We just drew adjacent angles to illustrate what complementary and supplementary mean. The complementary and supplementary applies whether the angles are adjacent or not. Those terms apply regardless, okay? So there we go. Complementary, supplementary, and adjacent. And a protractor. Now then, look at that. There's all sorts of fun with a protractor. Exponents and signed numbers. Okay, so we talked about that already. And so you'll notice that they actually use 4 here. I can't remember if I used 4 or not. But anyway, so see, they're talking about, they talk about if there's no parentheses, this notation, -4 squared, indicates the opposite of 4 squared. So in other words, here they're saying that you apply the exponent before you apply the negation, before you apply the negative sign. But if you what you really meant was the number -4 multiplied by the number -4, so the number -4 squared, then you would parenthesize it. You would put parentheses around your -4 and then square it. So I think that's the whole purpose of this lesson, is to clear that up. It's almost like a special case, but I guess it's not exactly, because exponentiation is fairly high in the order of operations, and so you would sort of assume that you would do the exponentiation first, but that could be confusing. If you saw this, you wouldn't necessarily know for sure whether you were taking the number -4 and squaring it, or you were taking the number 4 and squaring it and then negating the result of that exponentiation. Okay, so to repeat, read that. There you go. Here's some angles. Ooh. Okay. Advanced ratio problems. Now we have spoken about ratio problems like these ones that they're calling advanced, and it basically comes down to having multiple variables in your equation and being asked and being given all but one and being asked to solve for the one. So the fundamental form that any ratio problem takes is you have a ratio of A to B, and you are told that that ratio equals another ratio C to D. And invariably, you will be given 3 of these numbers and you'll have to solve for the 4th. Now, the example they give is something along, I'll give you a different example, but I'll put it in the same terms that they put their example. For example, let's say we got a bag, an infinitely large bag with infinite number of marbles in it. And for every, it's not an infinitely large bag, but let's say that we're told that in the bag there are 7 red marbles for every 3 blue marbles, okay? Now then, and there are a total of 320 marbles in the bag, okay? So you might be in a rush to write, hey, okay, we got, I've got my ratio here, 7 red to 3 blue equals, what do we put here? Because we're told that there's a total of 320. And so what you need to realize is that they've given you a ratio problem. They have given you a ratio problem, and they've given you 3 of the numbers. They just did it in a tricky way, okay? So rather than telling you there's a certain number of blue marbles or red marbles, so for example, let's say they told you that there are 7 red marbles for every 3 blue marbles, and there are 84 blue marbles, okay? How many red marbles are you? Well, then that would be a ratio that you could fill in here, because they're telling you that there for every 3 blue marbles there are 7 red marbles, and there's a total of 84 blue marbles. How many red marbles are there? Well, that's a ratio that that you can work out. You can write down this way. But what they told you was how many total marbles there are. So they gave you the numbers for a ratio, but it was a different ratio than what you were expecting. It's sort of hidden. And so what they're telling you is, they're telling you that for every group of 10 marbles, if you have a collection of 10 marbles, 7 of them are going to be red and 3 of them are going to be blue. Okay? So 7 red is to 10 total is how many red is to 320 total. Or if they gave you the same ratio, they said there's 7 red for every 3 blue, and there are 320 total, how many blue marbles are there? Well, then you would do the same thing, except you would replace the 7 red with a 3 blue, okay? So there's 3 blue for every 10 total, right? Because you've got 7 red to 3 blue. If you're holding 10 marbles in your hand, then the ratio that holds there is that there's going to be 7 of them are red and 3 of them are blue. So then if that's the way that it's stated, then what you would say is, I'm going to make it that a capital B because it looks too much like a 6. You would say, okay, 3 blue to 10 total is the same as how many blue to 320 total. Okay, so that's how they have sneaked their ratio in there. They gave it to you in a little bit of a sneaky way, but it's still a ratio problem. You just have to be able to recognize where, what the proper numbers for the ratio are. Okay, and then if you were going to work this, we would do our cross multiplication. Okay, and so you'd have 10b equals 3 times 320, and then you would divide both sides by 10. We could take that and multiply it out, but it's much easier to divide by 10 first, because whenever we divide by 10 over here, we just knock off a 0, right? And then we got 3 times 32. 3 times 32. 3 times 30 is 90. 3 times 2 is 6. That's 96. So if we have 320 total marbles, we have 96 blue marbles, okay? And we could figure out, well, obviously the remainder would be red if they're all red or blue. But we could also figure out, okay, how many groups of blue marbles do we have here? Well, if we divide this by 3, then we come up with 32, obviously. And so there's 32 groups of blue marbles. And so that means there's also 32 groups of red marbles. So if we say 32 times 7, 30 times 7 is 210, plus 14 is 224. So there's 224 red. And we can check ourselves by adding the 96 blue to the 224 red, 0 and a 1, 2 and a 1, and we get 320 total. There you go. So there's a couple of different ways to check yourself, but that's one of them. Okay, so that's kind of they call that an advanced ratio problem. So all it is being able to just bear in mind that all ratio problems are going to be two ratios set equal to one another, and you just need to make sure that you're dealing with the same, you've got the same numerator and the same denominator. Okay, so if you would have set that up as red versus blue marbles, and they're asking you how many red marbles there are, but they gave you the total number, you can't say A red is to B blue as C red is to D total, because then your ratio, you're setting two ratios that are unlike equal to each other, and that's not a valid setup for that problem. So you would have to you would either have to be able to figure out what the number of blue marbles are and set that equal to that, or you'd have to change your ratio so that it's some number, T total. A red is to T total as C red is to D total, okay? And we talked about how to do that. So it's a simple matter of setting up your ratio problem the proper way and recognizing the numbers that are involved, okay? And they take you through a few examples. I would suggest that you work through those just to make sure that you have it. They talk about nuts and bolts, and they talk about wheat and corn, and they talk about professionals and amateurs. So look through those problems, and I think that you will understand well. And please text me or call me with any questions that you have, and I'll be happy to answer them in particular. I can do another video, or I can call you. I can do my Marco Polo, just whatever you want. So please let me know if you have questions or if I need to go over something in a little bit more detail. Okay, have a good week.